Next, subpartition template. Now we need to specify the template for subpartition. Within the brackets we specify subpartition SP1 values less than 1000, because the inner query also range partition. Less than 1000, less than 2000, less than 3000. Subpartition is closed. Come to the main partition. P1 values less than 10, P2 less than 20, P3 less than max value. So when it comes to the main partitioning, there are 3 partitions, P1, P2, P3. P3 is the default partition, otherwise there are 2 partitions, values less than 10, values less than 20. That means value cannot be more than 20 in this case. Table is created. Next, EMP range we have seen. Now range list. Main partition should be range partition, sub partition should be list partition. Here we specify subpartition by list of ename. SP1, SP2, SP3 values A, B, C, D, E, F, X, Y, Z, and main partition is range partition. Here table is created. Next, range hash. Initially it should be range hash. This is range hash partition. First it will be range partition, and in the sub partition it will be hash partition. We have 2 partitions, or simply we can say sub partitions with number. Sub partition by hash of salary, sub partitions 3. We need not specify partition names, all the 3. Max value is for range partition. This way also table is created. Now let us come back to list. List range. Up to 10G it is not allowed, only in 11G it is allowed. We define the columns. List range. Subpartition is range, range of employee number. Main partition is character. ABC. This is list main, range subpartition. Similarly, list, both are list. Main partition is also list, subpartition is also list. Only in the main partition we can see values less than. In the main partition we don't see the keyword values less than. See here we have specified the list of values since it is list partition. If it is range partition we specify values less than. Here we specified values. If it is A or B or C, all the values will go to first partition. In the sub partition, from the first partition we are picking A, B into second partition, C into third sub partition. These are sub partitions within the partition. And when it comes to the first partition, again we have sub partition. When it go to the second partition, again there are 3 sub partitions in that. D will be one sub partition, E will be another sub partition, F will be another sub partition. In partition 3, totally we have 3 values x, y, z. X is one partition, one subpartition, y is another subpartition, z is another subpartition. Similarly, we go with hash. Main is list partition, subpartition is hash partition. So in hash partition, we can go with either subpartition names or simply subpartitions 3. In 10G it will give error because this feature was not there in 10G. 11G it will create. See, table created. Now hash range, it has given error. Hash range, another method also error. Hash list, hash list is error. Another method of hash list. Hash is also error, both the methods. So starting with hash as main partition and other as subpartition, this type of combinations are not present till Oracle 11G and even 12C also. So that's all about hash partition. Now let us see interval partition. We know that in case of interval partition, partitions will be created automatically. We need not create the partitions by manually. As and when the data comes into the table, the new partition will be created automatically. This is the main advantage of interval partition, but interval partition is introduced only in 11G. Before that, this type of partition was not available. But while creating interval partition, we need to specify at least one base partition, and this base partition must be range partition based on number column or date column or timestamp column. So to create an interval partition, the table must be range partitioned based on number column or date column or timestamp column only. This is the restriction we have, and we need to specify at least one partition which is the base partition. Along with this, we need to specify the interval or the partitioning key, whether we are going with daily partition, hourly partition, monthly, weekly, yearly, quarterly. That particular component time interval we need to specify over there. There are other restrictions that we see later. Let us create a table first. This is normal T part interval. Up to here it is normal syntax. Create table, table name with column list. Then the partitioning clauses will start. Partition by range of person ID. Person ID is a number. We can use it. Next, interval 100. The interval is 100. 100 we do not know whether it is 100 minutes or 100 days or seconds or weeks or 100 years. That we do not know here. So database cannot understand what is this 100. That is why it has thrown error. Partition P1 values less than 101. This is the base partition, and then we can specify the table space, which is optional. Here also we can specify the table space name, which is optional, so it is not required. Since it cannot understand, the database cannot understand what is 100, it has thrown error. Missing or invalid option. near interval means for the value 100 it is showing error. So it should be a time interval, a time period. We need to explicitly specify whether it is 100 minutes or seconds or hours or days, weeks, months, years, like that we need to specify the number here. Now let us see what are the restrictions we have with interval partitions. What are the rules and what are the restrictions? The rules on interval partitioning table is very few. The table must be range partitioned. The range partition must be placed on number column or date column or timestamp column, or it can be time interval. At least one base partition must be specified. We must use a number over there, but the number whatever we specified, it should be understood by the database in terms of days or weeks. These are the conditions for interval partition. Now let us see what are the restrictions on interval partition. Interval partitioning is restricted to a single partition key. That means multiple columns are not allowed in the partitioning. We cannot partition the table based on multiple columns. Interval partition is possible based on a single column only. And this single column must be a number or date range. When we say date range, it can be date or date time. Date time means timestamp, or it can be time interval, interval literal. So only these type of data types are allowed for the interval partition, but originally the table is range partitioned. We do not specify their interval partition like that. Partition by range, we don't specify partition by interval. It is range only on numeric or date column, but the interval should be there. In that interval we specify the number of days or something. Now let us see one more. At least one partition must be defined when the table is created. This is called as base partition. So at least one base partition must be defined while creating the table. Interval partitioning is not supported for IOT, index organized table. Index organized table cannot be partitioned based on interval partition. So interval partitioning cannot be implemented on IOT. Domain index cannot be created on interval partitioned table. It is a type of index. That index cannot be created on interval partitioned table. Interval partitioning can be used as the primary partitioning mechanism in composite partitioning, but it cannot be used at the subpartition level. Interval partition can be used as the primary partitioning in the composite partition. It cannot be used at the subpartition level. Interval partition cannot be a subpartition. It can be a major, it can be the primary partition, not the subpartition. That is why we have interval range, interval list, interval hash. We don't have range interval, list interval, hash interval like that. A max value partition cannot be defined for an interval partitioned table. Even though the table is range partitioned, we cannot specify max value partition for interval partitioning table. Null values are not allowed in the partitioned column. Whatever the column is used as partitioning key, We cannot insert null values into that column if it is interval partitioned. So these are the restrictions on interval partitioning table. Next is reference partition. We will see the practicals on interval partition later. We will see all other partitions which are introduced in 11G. We will see what is that, what are the features, what are the conditions, what are the restrictions on each partition, and then we move on to the practical session. Reference partition. This is also introduced in 11G. This is to support partitioning on the foreign key columns. So when the parent table is partitioned based on the primary key, the corresponding foreign key column will not be partitioned by default. If we use the reference partition, then the foreign key column will be partitioned. Reference partitioning allows tables related by foreign keys to be logically equipartitioned. So whatever the tables are related by foreign keys, all those tables will be logically equipartitioned. The child table is partitioned using the same partitioning key as the parent table. Whatever the partitioning mechanism we have used for the parent key in the parent table, the same mechanism will be implemented for the foreign key column, the table of the foreign key also. Without having to duplicate the key columns. Partition maintenance operations performed on the parent table are reflected on the child table also, but no partition maintenance operations are allowed on the child table. So whatever the maintenance operations are performed on the parent table, the same operations will be performed on the child table, but no maintenance operations can be performed on the child table directly. If at all we want to perform any maintenance, that must be performed on the parent table only. We cannot perform any maintenance operations on the child table directly. The conditions. The child table must specify a referential integrity constraint defined on the table being created. This constraint must be in enable validate no deferable state. By default, when we create foreign key constraint, it will be enabled and it will be validated. So we need not bother, but if at all it is not in the enable validate not deferable state, we cannot use reference partition. So this is the default option. If we create the foreign key constraint with the default option, definitely it will be in the enable validate state. And foreign key will definitely refer to primary key and unique key, so we need not bother about this. The foreign key columns referenced in the constraint must be not null. The foreign key columns referenced in constraint must be not null. So we should not have null values over there. The constraint cannot use on delete set null clause. When we define the foreign key constraint, we should not use on delete set null clause if we want to use reference partition, because there should not be null values into that. So whenever we delete the parent record, it will place a null value in the field of foreign key column if we have on delete set null. If we have null values, we cannot use reference partition. That means when we have null values in the foreign key column, we cannot use reference partition. So there should not be null values in the foreign key column. That is why on delete set null clause should not be present with foreign key constraint. This is for reference partition. The parent table referenced must be an existing partitioned table. So whatever the primary key or unique it is referencing, means the foreign key is referencing, that table must be a partitioned table, because that is the table we are going to make partitioned table through reference. All partitioning methods except interval partitioning are supported. To create a reference partition, all partitioning methods are supported except interval partition. This was the drawback. So when we use interval partition, the reference partition, that is the foreign key column, will not be partitioned because reference partition is not allowed on interval partition. To support this, in 12C we have interval reference partition, but in 11G this is not allowed. The foreign key cannot contain any virtual columns. The foreign key column cannot be a virtual column. This is another restriction. The referenced primary key or unique constraint on the parent table cannot contain any virtual columns. Not only the foreign key cannot contain virtual column, the primary key or unique which is referencing by the primary key, foreign key, should not contain any virtual column. Reference partitioning cannot be used for IoT, external table, domain index storage table. So we cannot use index organized table, external table and domain index storage table for reference partitioning. A chain of reference partitioned tables can be created, but constraint used cannot be self-referenced. We can use a chain of referenced partitioned tables. That means first table is referencing the second one is referencing the third one is referencing the fourth. All the tables can be used with reference partition, but a constraint cannot be self-referenced. It cannot be self-referenced. That means the same column cannot reference to itself. The row movement setting for both tables must match. If at all we specified row movement, enable row movement, it should match for both the tables. Reference partitioning cannot be specified in the create table as select statement. So we cannot specify the reference partition when we create a table using select as, that is CTAS, create table as select, like this. These are the restrictions for reference partition. Next is system partition. This is like our hash partition. So in hash partition we specify only the name of the partitions or number of partitions. We do not specify the range of values in the hash partition. So when we insert records into hash partitioning table, we do not have any control where the record will be inserted, means in which partition the record will be inserted. So we cannot take the control while inserting the data into the hash partitioned table. The database decides, or the optimizer decides, where the record has to be inserted. To take the control, we have the system partition. System partition is introduced to take the control of inserts. Where do we want to insert the data? That is the advantage of using system partition. System partitioning gives you many of the advantages of partitioning, but leaves the decision of how the data is partitioned to the application layer. So instead of taking the decision by the database, we are leaving the decision to the application layer. For the UI, the application layer decides where the data has to be inserted. The conditions or restrictions. If we specify the partition by system clause but don't define partitions, we just specify partition by system and we do not define the partitions, a single partition is created with the name in the format of sys underscore some number, which is generated by the database. So if you don't specify any partitions, a single partition will be created. If we specify partition by system, partitions n, we just specify the number of partitions, then so n number of partitions will be created and the names will be generated by the database automatically. So if you want to specify the number of partitions, what is the number that can be used? Minimum is 1. We cannot say number of partitions as 0. So it should start with 1. Minimum is 1 and maximum is 1024k minus 1. 1024 into 1000, that is 1024,000 minus 1, that is the maximum number. So we cannot specify the numbers outside this limit. It cannot be less than 0, it cannot be beyond this number. System partitioning is not available for IoT or the table that is part of cluster, that means clustered table. We cannot use system partitioning on IoT and clustered table. System partition can play no part in composite partitioning. It cannot play any role in composite partitioning. We cannot split a system partition. Splitting the partition is not allowed in the system partition. This is one restriction. And while create table as select statement, we cannot specify the system partition. As we have seen in earlier session, when we create a table, when we create a copy of the partitioned table, the target table, the new table will be a normal table only. The data will be copied, structure will be copied, but the partitions will not be copied. And we must always specify the partition name when we insert data into the system partitioned table. If we do not specify partition name, it will throw an error, because we are taking the control while inserting the data into partitions of the partitioned table. So we must specify the name of the partition. So whenever we insert, definitely we have to specify the partition name along with insert statement, along with the table name, to which partition we need to insert the data. In case of update and delete, we can update without partition name also, but it is always advisable to use partition name to make the updates or deletes as faster. virtual column partition. As virtual column is introduced in 11G, they have also allowed the partitioning on virtual column. So normally virtual column does not store any data physically in the column. The data will be derived during the selection. So whenever it is required, the data will be derived based on the columns or expression we specified in the virtual column. So we can use the virtual columns as a partition key while creating the partition. This is allowed. So virtual columns are allowed for creating partitions based on the virtual column. That is why when we use virtual column in the as a partitioning key, then that type of partition is called as virtual column partitioning. Means the virtual column is partitioned. Partitioning method can be anything. Interval reference partition. This is the new partition method which is introduced in 12C. This is to support reference partition for foreign key column with interval partition. When we use interval partitioning method for the parent table, the corresponding foreign key table, the child table, cannot be reference partitioned. To support that, we have this kind of partitioning method. So when we partition the parent table using interval partition, whenever using interval reference partition, whenever a new partition is created for the parent table, automatically a new partition will be created for the child table also. That is the advantage. Now let us see the practical session. Interval reference partition. The remaining partitions we see later.